comes, look, the time value of money. So I start with a really easy number. How about that? I'm going to go from left to the right? So left is present value, right? So future value. If I go left to the right, you are calculating for future value, such as your saving. Are you saving for your next car? Gerard, are you saving for your house, $10 million house 20 years from today? So to be able to buy that house in Los Altos Hill, 20 years, how much does he have to save every month? So people do that? Yeah. Big ticket item, people do that, right? You plan. So that going from present to future, am I right? So that's left to right. And then sometimes people do that also backward, future to present. Okay. How much would it be? If someone tells me, I'm going to give you $100 1 year from today, that's the future. But what would be the same equivalent amount if the person pays me today? So that's going from right to the left. Okay. So now I'm going left to the right first because it's a little bit easier. So I just use $100. $100 today. How much is it 1 year from today? Well, you didn't tell me something. What did I didn't tell you? Yeah, what's the interest? Well, for the sake of easy, simplistic illustration, I'm just using 10%, right? And no bank will give you 10% these days. You are lucky if you get 1% these days, right? And then we are not touching the money. We just leave it in the bank. So year from today, Joanne? 110. 2 years? We are not touching the money. You are not taking out anything. You just leave it for 2 years.
121.
121? I just do the 2 years. Yeah. Anybody just wondering? Okay, 110, how do you get that? 100 plus 100 multiplied by 10%, that's 110. How do you get 121? 110 plus 110 multiplied by same interest rate, 10%, 121. So far so good? Anybody, did I lose anybody? So I'm going to ask Ben, how about 5 years from today? You want me to do this 5 times? How about 10 years from today? You want me to do this 10? I mean, he can get it, but it takes time and it's very cumbersome, right? Lots of pushing the calculator and all that. Can you do a little bit faster? All right, faster. What can you do now? Did you notice something in repeated pattern? Right? So instead of doing every time, how about nth power? If we do it twice, 2 years is a power of 2. If you do 3 years, power of 3. I is a 10%. So 1.1, am I right? 1.1. Power of 2 multiplied by 100, the present value. So future value equal to present value multiplied by 1.1 second power. Does it come out to 121? Am I right? Does it, Alicia?
Yes.
I don't have a calculator on me. I just want to make sure I don't make any error. So present value in this case, 100. 100 multiplied by 1 plus interest rate, in this example 10%, 2 represent n equal 2. Did I lose anybody? You don't have to do this way. You also can do what? Tables. It's in your appendix C of your textbook, as well as where? In chapter 15. It's a future value table. It's universal, same. Okay. Do you have to memorize this before final? The instructor has to provide this because otherwise you have to buy financial calculator. I don't want you to go shopping for that. Right? You don't need. Or website, or those who are taking math class, formula. So you have 4 different ways. But table, it's good to know for table. So luckily there's 10% column there. Oh, I like that. And then what's the N? N?
2.
2 years. 10% 2 years. 1.21 multiplied by $100. Is that 121? Is that 121?
Yes.
Bingo. So Appendix C of your textbook, chapter 15, also replicates some of the table as part of the chapter lecture there. All right? So far so good. So now I'm going backward. All right? So would you please pretend you have not seen this number? Just pretend. So I'm gonna talk like this. Okay? Edward. Someone making a statement, Edward now. Edward, I'm going to give you $121 to you exactly 2 years from today. And prevalent interest rate at the time was 10%. Edward wants to know how much is the present value of the 121, the person telling you. So if I'm getting that money today instead of waiting for 2 years, what would be equivalent value? Someone telling you $121, exactly 2 years from today. Is it more than 121, less than 121, or same as 121? You will say, well, 121 is one $100 bill, one $20 bill, one $1 bill. How's this different? Nominally, in terms of physical money, it's the same. I agree. Right? Especially if you put $100, $21, put under the apple tree in your backyard. That's going to be exact same $121, right? 2 years from today, right? How about under the mattress? Same thing? But we are not talking about that. We are financially, present value, future value, time value of money at interest rate of 10%. Okay? Would you like to try? Would you like to try? No? Nobody? Okay, answer it was here all the time. So instead of getting future value, what I'm getting? Present value. So can I rewrite this algebraic equation? PV equal to FB divided by 1 plus I n's power, right? So it's 2 years. So present value equal to future value is given to you. You already knew the answer, but you pretend you didn't know the answer, right? Thank you for pretend not knowing the answer. So $100, bingo, $100 is in equivalent to today's dollar. Okay? Question, comment? Easier than you think, right? I hope. So now the present value. Do I have present value table? Yes, I do. Okay. So 10%. Two, period 2. I know this, the period 3 was highlighted, but period 10%, period 2, what's the factor? 0.82645, am I right? Multiplied by, we are getting present value. You are given future value, multiplied by future value given, 121. So to any calculator, could you please punch 121 multiplied by this factor, 0.82645. So there's a rounding, right? It's $100. It's close enough, $100. I just want to prove that to you. Because the table has a limitation because, the limitation of carrying the digits. But $100, she said.